Okay, so we're looking at these absolute values, but we're pretending like instead of one function, they're just two separate rates. Right now we're working on the equation for the left side. We found the slope. Now we need the y-intercept. Well, this one doesn't cross the y-axis, but if it kept going, down 1 over 1, down 1 over 1, do you see what the y-intercept would be? Yes. What is that point? Negative 6. Okay, now, the line doesn't keep going though. It stops right here. So yesterday we talked about how to restrict the domain to make it stop. So it goes forever left. What's forever left? Negative infinity until right here. What's that x value? Negative 2. It's the x value, negative 2. Okay, so that's how I could write it as an interval, and you're certainly welcome to do that on your quiz next week. Or we could write it as an inequality. These two mean the same thing.
We're not allowed to do, in my class, you're not allowed to do the top one, we're not allowed to do the bottom.
You're only allowed to do the bottom? Oh.
She didn't say that in my class.
Huh.
Mr. Libby said we can use both.
I did. I like both.
Me too.
I'm pretty fond of both.
It just makes more sense to me. The top one does because it's visual.
Okay. Well, maybe we can talk about that today. And I'll see their reasoning. I'm sure it's good. All right. Now the pink side, the right side. Up 1 over 1, up 1 over 1, up 1 over 1. It's a positive 1. And then this one, you can actually see the y-intercept. What is it?
Negative 2.
Negative 2. Now this starts at negative 2, and it goes forever right. Now, one thing I want to talk to you about. When we're taking one function and breaking it up into multiple functions, if they share a point, like this one, they share the vertex. The left side and the right side have the same point. What you have to do is include it with one, but not with the other. And it doesn't matter which way you go with it. So you could have your inclusion here and not here, or vice versa. We could not have it here, but have it here. So either one would be correct, but you can't include it for both. Yes, ma'am.
Is it the negative 2, is that supposed to be bracket, or is it supposed to be parentheses? Or the
I
bottom
chose
one?
bracket here, so I have to use parentheses here. We can't have brackets in both places. Yes,
So you
ma'am.
could just choose one.
You choose one. You choose one and the other one doesn't get it. All right. Let's take a look at equation number 2. So now we're going to look at the left side first. I'm going to make the left side green again. And then we'll go to the right side. So we're going to do left and right.
So, Miss Willoughby, you
Yeah.
only make one bracket before that one.
Correct. Only one of them gets the bracket. All right, left side. This one has what kind of slope? Okay, pick any point to get to the next one. Down 1, right 1. Down 1, right 1. Okay, so that's going to be negative 1. And this one, we can see the y-intercept. What is that y-intercept? 5. Now, that one goes forever left, so it's from negative infinity up to this x value. What is that x value? 3. Now, just to show you that it doesn't matter, I'm not going to include it here. So since I do not include it, I do not have the equal to.
Why is it, like, why can't we use both?
Well, because with a function, when we have an x value, we only have one y value that goes with it. So we would only want to include that x value once. And you're going to see, because soon we'll have functions that are crazy looking, like they'll have an open circle here and a closed circle there, and they don't connect. They could look crazy like that. So we're training ourselves to be ready for problems like that.
Okay.
Okay, now, the next one's the right side, and its slope is positive 1 again. Up 1, right 1, up 1, right 1, positive 1. Now, this one doesn't cross. We can make it see where it would cross if it kept going. If it kept going, it would cross at -1. And since I didn't include the 3 earlier, I should this time. Since I didn't include it before, I should this time. So you get to pick. Okay, now I want to show you kind of a shortcut. With the left side, we do the opposite of what's in the absolute value. With the right side, we do the same of what's in the absolute value. Let me explain what that little trick means. Even if I didn't have the graph, I could work this problem. I'm going to cover up part of my graph and give me a little writing space here. Okay, so for the left side, I said, for the left, we could do the opposite of everything that's in the absolute value. So for the left side, if I did the opposite of that, that would become a -x and a -2. Is that the opposite of everything? Okay. Now, there's nothing to distribute, so I can just drop the parentheses. Do you see the equation I get for the left side if I do the opposite of everything is -x minus 6? Is that what we have? Y'all see how this matches this? Okay. Now, let's do the right side. Yes.
So you changed the absolute value to what?
Yes, you change the absolute value to parentheses and do the opposite of what's inside. Yes, ma'am. Okay, so here on the right side, we do the same. So nothing in the absolute value changes. You just change the absolute value to parentheses. Now, the parentheses don't really help us this time. If we had a number out in front, the parentheses would be important. So here, I just add like terms. X plus 2 minus 4 is x minus 2. What was that second equation? X minus 2. Okay, let's look at the second one we did. If I did the left side, I do the opposite. So for the left side, I would do the opposite. So this would become a -x and a +3. So then when I add like terms, I get -x plus 5. Is that what we had when we looked at the graph? Yeah. Okay, let's go do the right side. So for the right side, we don't do the opposite, we do the same. So for the right side, we would do the same. And we get y equals x, -3 plus 2 is -1. That's what we got.
Miss Willoughby, can I get one of those sheets for me color coded?
Oh, yeah. Good. Let's see, which one does support? Here, this is my master copy, so I know it's just not front and back.
Oh, okay. So is this just for like solving like when we don't have the graph?
Correct.
Okay.
Yeah. All right, so number 3, we have the graph. So we can do it graphically, and then we'll go back and look at how we could do it algebraically if we didn't have the graph. All right, so I'm going to color my left side a different color, and then I'm going to go back and color my right side a different color so we can clearly see that this absolute value is really made up of 2 rays, 2 lines. So let's do the left side. The slope is it is hard to tell because I don't think I quite drew that right. There we go. It should be up 1 over 1. It should be like this. Mine got off a good bit. So it should be up 1 over 1, up 1 over 1. So the left side is actually a positive x. And so if I went up 1 over 1 again, it would cross at positive 1. Okay, so that goes forever left up until right here at negative 1. So that's x values that are less than or equal to negative 1. Okay, and the right side. The right side is down 1 over 1, down 1 over 1. So the right side has a negative x, and it crosses at negative 1. And that starts at negative 1 and goes to infinity for x values that are greater than negative 1. Okay, so let's go back and see if our trick we talked about a second ago to figure out the left side and the right side. So for the left side, we do the opposite of everything. So this becomes y equals negative, and we do the opposite. Well, what does this negative out in front do with those opposites? And it changes them. They become positive, don't they? Is that what we have? Yeah. All right, let's do the right side. So the right side, nothing changes on the right except the absolute value we write as parentheses. So now we got this negative out in front that we have to distribute. And is that what I got on the right?
This always works.
Yes. This is an always works situation. Those are my favorite kind.
So like if we like kind of if we like graphed it wrong, or not even graphed wrong, but like if it like goes through like the middle of the 2 points, like not on the point.
Yeah. Yeah. So if you can't see where it would cross, or you get ugly, like one of the problems on your regular homework has fractions in it, that might be easier to do this way. Oh yeah. So there's lots of times that way is easier. Now, I want us to skip over to the back, and I want you to try let's do number 6 together. We're still going to do one more together because this one has a 2 in it. I want to show you what happens. All right, so the first thing we have to do is graph it. So you graph it. We'll try number 6 now. Yeah. That just shifts it partially, yeah.
Yeah, but whenever you try to line the one, like there's another one there, so it's like right here. So whenever you try to dot it,
Yeah.
like right here,
Yep.
and then like right here.
Yep. That's exactly what would happen. Bless you.
Thank you.
Okay, so this one starts at -1, -3. And because of the 2, we go up 2 over 1, up 2 over 1. And that's what this one would look like. So I'm just going to go ahead and graph it with 2 different colors. Green over here, pink over here. All right, so we're going to write it as the 2 separate equations. So this is what it's going to look like. The first thing we're going to do is the left side. So for the left side, it's down 2 over 1, down 2 over 1, down 2 over 1. So we get negative 2x. Now if I went down 2 and over 1 more, what would the y-intercept be? Negative 1, 2, 3, 4, 5. Now, we have to restrict the domain. This goes from this point forever left. So it goes from negative infinity to negative 1. Or if you have to write the inequality, it's x is less than or equal to negative 1. Guys, the inequalities aren't too bad on these, and let's talk about how you can know. If I drew in like a little line right here, where it kind of switches, this side is this side. Look at this arrow right here. Doesn't that arrow match that inequality? And then when we go to the other side, I should have done that one in green. So this side, the arrow matches that inequality. This side, the arrow going this way would match the other inequality. So that's kind of helpful. This would be up 2 over 1. And this one has a y-intercept of negative 1. So this would go from negative 1 to infinity. Or x is greater than negative 1. So they should match. They should match which side of that line you're on. Okay, so for me, I'll take either one of these. If your teachers want the inequality, there it is, okay? All right, I want you to try these two. Okay, so first you're going to graph it, and then you're going to break it apart. Take that absolute value and rewrite as the two lines that form that absolute value. Yeah. If you did 1.5, you go over 1. But if you did it here, it would be like up 3 over 2. So you, yes, this slow. Yes, sir.
So is it better to do this slow?
I would do slow. Yourself, chiropractic hand. Okay, if you go left and down, that's a negative and a negative, which turns it into a positive.
So, 3x minus means 5.
Mm-hmm.
And then for this second.
Okay, wait a second. This was right for this side, but if I do positive 3, you have to do it one more time to figure out that this side would intersect right there.
So this is for this side.
Yeah, this negative 5 is for this side.
Okay. Do you go up 3 over 2?
This side is, this side I think over 2 is right there. Up 3 over 2 is right there.
I'm not going to
Yeah. Cause I didn't have a live Friday night. But that Friday night, so I kind of went. And now, like, I kind of don't want to go. This would be my first game I'll miss if I don't go to this one.
I like basketball games.
Yeah. But still, this would be my first one. And I'm like so shocked.
I'm not going.
I probably will either.
Isn't it in Riverdale?
It's afterwards. Yeah, it's in Riverdale.
The only game I've ever been to was a baseball game. I didn't know what was going on.
Baseball's so boring. It's the hot lights on.
But if the light's not on, then don't go. It's not worth it.
One time, we were like, my mom was going fishing.
They don't have
We
like
went past my Krispy Kreme,
to stop.
and the hot side was on. And
We ain't going fishing no more.
Got through traffic. And we saw Krispy
They only use your camera.
My mom, she's like, if
I'm with her. That's the only time I'll cross like 4 lanes of
my
traffic.
mom's like, if I'm
If the hot sign
like,
suddenly
to the
comes
point
on,
where I'm not gonna be able to
then, I mean, you really don't have a choice. You're really just supposed to cut everybody
No,
off.
you understand? My mom heard. If me and my sister and
You
her
get
friend are
your
just holding on.
That's not bad.
We're just holding on to the seat.
If the hot sign's
It's
not
worth
on,
it.
it's
It's the
kind
hot
of
side.
like,
Your death is worth
death is worth it.
Your life is worth it. As long as I get some hot Krispy Kreme.
Alright.
They had Kit Kat donuts for so long. I was like, you can eat them.
Alright, so here we go. Left side. Down 3, right 2. So it's negative 3 halves, x, 1, 2, 3, 4, plus 4. And those are for the x values that are less than or equal to 2, which you would write like this. Okay? The right side is the positive. And if I kept going, it would intersect down here at negative 2. And those are for x values that are greater than 2, which would look like this. Okay, next one. The translation point is negative 1, negative 2. And just for fun, we made this one open down to where you don't have much room. Just for fun. Okay, so left side is up 3 over 1. So positive 3x. Now if we did that one more time, it'd have a y-intercept of plus 1. And those are for x values that are less than negative 1. Or from negative infinity to negative 1. Okay? Right side.
Wait, why is it plus 1? I thought it was negative 5.
Okay, the green one right here.
Okay.
The green side for me. Here, I have to figure out where it would intercept the y-axis. It doesn't right now. The green side doesn't. So I'd have to count the slope again. Up 1, 2, 3, right 1 to figure out what the y-intercept would be. Okay, do that. We'll do algebraic next. Yeah.
You know, I just realized when you do like the greater than or less than, like it would be pointing towards the infinity.
Yeah, it does. It does. You're
Like,
right.
it point towards like the infinity.
You are right.
I believe she showed you on what's over my
I know, but I'm realizing like the.
She's tying it to the infinity part.
Olivia, how did
Wherever the infinity is in the interval,
I suggest.
that's what she's tying it into. Okay, so let's say you like that algebraic way. So if you like that way better, for the left side, we do the opposites. Okay, so we have to distribute this time, which makes it positive and positive. So it would be y equals 3x plus 1. Is that what we had? Yeah. Okay, let's do the right side. The right side's a little easier because you don't have to change anything. You just distribute. So the right side looks like this. Nothing changes except the absolute value go to parentheses. And then we distribute. So it's negative 3x minus 5. Okay, so that's algebraic. Whichever way you like. Whichever way works best in your brain.
I got all the algebraic ones right on my test. So
Cool. All right, then let's go with that one. Okay. Let's go back now and do these. Flip it back to the front.
Miss Willoughby asked if I'd been to your class yet when I was in there. I said, no, and she said, well, there's like a trick or something how to do this, and I don't remember how to do it. So, there's a
Oh, that's
trick.
one is pretty.
Is there?
A trick for what?
The algebraic.
This right here?
Yeah. That's
Yes.
what she was doing.
There's a trick.
All right.
I'll say A.
Okay, so now we're going backwards. If you have the two pieces, it's not really a trick, but it's something we can just see happening, a pattern, time after time after time. Okay, so hopefully you noticed that the right side always has the same sign. The right side always has the same sign. The right side always has the same sign. Did you notice that? The right and the same. Right is the same. Right is the same. Let's go look at the rest of them. The right side was a positive 2x. Is that a positive 2x? The right side was a positive 3/2. Is that a positive 3/2? The right side was a negative 3. Is that a negative 3? Okay, so the right side always tells us how we start. Is it positive? Is it negative? Okay, so on this one, the one that's pointing to the right is the right side. So this top one is the right, the bottom one is the left. So the right side tells us that this function has a negative 1 out in front. Or just a negative, because 1 doesn't really matter, does it? It could just be a negative. All right? So that's the first thing we need to know, because the right side tells us whether it's positive or negative. Okay, so this one, the bottom one is the right side, and the top one is the left. The inequalities point which direction we go. The top is the left, the bottom is the right. Now, if I'm writing one, I always go left on top, right on bottom. But if you're given one, it may not always be that way. All right, so the right side has a 2x. Well, this one's going to start with a 2 out in front. This one had a negative x, so it starts with a negative out in front. Okay, now, one other thing that we can go back and pay attention to. Did you notice that every time down here, this is the x value at the vertex? These numbers are the x value at the vertex. These two are the x at the vertex. So, guess what the x at the vertex is for this problem? -1. So the x at the vertex are those numbers. So if this is -1, what goes in here? X
Plus 1.
plus 1. Okay? If these are 2, what goes in here? X minus 2. Good. All right. So we've done everything but the y. Okay. So to find the y, there's an easy way to find the y. Now that we know what the x is, to find the y, all I have to do is pick which one of these looks the easiest. To me, the bottom one looks the easiest because it doesn't have negatives in it. And if the x is -1, when I plug in -1, I get -1 minus 1. So the y is -2. -2. Okay, and it really didn't matter which one I plugged it into, I would have gotten the same thing. Now this one, the x is 2. So which equation looks easier, the top one or the bottom one? Bottom. Okay, let's go bottom. So we plug in 2. What is 2 times 2? 4. And that's all there is to it. So the right side gives you the leading coefficient. And whether it's positive or negative. The inequality part gives you the x at the vertex. And then the last thing we did was we would plug that x into the easiest equation to get the y. All right, and that's it. That's today. So I think we've had enough good practice today.